Welcome to Ado Automate Hub. Today, we're exploring one of the greatest mysteries of all time, the origin of the universe. How did it all begin? Join us as we journey back to the beginning of time itself, diving deep into the Big Bang Theory and how it shaped everything we know. The Big Bang Theory is our best scientific explanation for the beginning of the universe. According to this theory, the universe started from an incredibly small, dense, and hot state around 13.8 billion years ago. In a fraction of a second, it began to expand, eventually forming stars, galaxies, and everything we see today. This expansion didn't occur within space, it was the very fabric of space itself expanding. So, what exactly happened during the Big Bang? The theory suggests that in the very first moments, all matter, energy, and forces were united in a single point, known as a singularity. Here's a breakdown of the key stages. The initial singularity at the moment of the Big Bang, all of the universe's energy and matter were packed into a space smaller than an atom. Temperatures were unimaginably high, and all forces, gravity, electromagnetism, and nuclear forces, were combined in a single force. The inflationary epoch, a fraction of a second after the Big Bang, the universe underwent a rapid expansion known as cosmic inflation. During this period, the universe expanded faster than the speed of light, growing from subatomic to astronomical scales. Formation of fundamental particles. As the universe cooled, particles like quarks and electrons began to form. These particles would eventually become the building blocks of atoms. Creation of protons and neutrons. About 1 second after the Big Bang, quarks combined to form protons and neutrons. These particles later became the nuclei of the first atoms. The formation of light elements. Around 3 minutes after the Big Bang, the universe was cool enough for nuclear fusion to occur, forming light elements like hydrogen, helium, and a small amount of lithium. After the formation of light elements, the universe entered what's known as the Dark Age. During this time, there was no light because the universe was still too hot for atoms to hold onto their electrons. But after about 380,000 years, the universe cooled enough for electrons to bond with atomic nuclei, forming neutral atoms. This process, known as recombination, allowed light to travel freely, giving birth to the cosmic microwave background, a faint glow we can still observe today. This first light provided the earliest snapshot of the universe. With the universe finally transparent, tiny fluctuations in density led to the formation of stars, galaxies, and larger structures. The formation of stars, clumps of hydrogen and helium gas, began to collapse under gravity, igniting nuclear fusion and creating the first stars. These stars played a crucial role in creating heavier elements, as fusion within stars produces elements like carbon, oxygen, and iron, essential for life as we know it. The formation of galaxies. Gravity continued to pull stars together, forming galaxies, massive systems of stars, planets, gas, and dust held together by gravity. Some galaxies merged over time to form larger galaxies, eventually leading to the structure of the universe we see today. The role of dark matter. Invisible but crucial, dark matter made up a large portion of the universe's mass and acted like a cosmic web, holding galaxies together and aiding in their formation. While we can't see dark matter directly, its gravitational effects are essential for the structure of the universe. Several lines of evidence support the Big Bang Theory, making it the most widely accepted model for the origin of the universe. Cosmic microwave background, CMB, discovered in 1965. The CMB is a faint glow left over from the early universe. This radiation is incredibly uniform, providing strong evidence of a hot, dense beginning. Redshift and expanding universe. Observations by astronomer Edwin Hubble revealed that galaxies are moving away from us, and the farther they are, the faster they move. This redshift, or stretching of light, shows that the universe is expanding, just as the Big Bang Theory predicts. Abundance of light elements. The Big Bang Theory accurately predicts the amounts of hydrogen, helium, and lithium observed in the universe. The high abundance of these elements matches what we'd expect from the intense nuclear reactions shortly after the Big Bang. One of the biggest questions is, what happened before the Big Bang? This question is tricky, as our current understanding of physics breaks down when we try to describe what existed before the singularity. Some theories propose that the Big Bang was just one event in an endless cycle of expansion and contraction. Others suggest the existence of a multiverse, where our universe is one of many that could emerge from quantum fluctuations. Ultimately, we don't yet have a definite answer, but the question continues to drive scientific exploration. The Big Bang Theory also opens up possibilities about the future of the universe. Will it continue expanding forever? Some scientists believe it will result in a big freeze, where stars burn out and the universe becomes cold and dark. Others suggest a big rip, where the expansion accelerates so much that galaxies, stars, and even atoms are torn apart. Alternatively, the universe could eventually stop expanding and collapse in a big crunch, leading to a possible cycle of rebirth. The Big Bang Theory gives us an awe-inspiring glimpse into the birth of the cosmos, shaping our understanding of space, time, and existence. Although there are still many mysteries to unravel, the journey to understanding the universe's origins continues to push the boundaries of science and imagination. Thank you for joining us on this deep dive into the origins of the universe. Make sure to like, subscribe, and hit the bell for more explorations of cosmic mysteries and the latest scientific discoveries.